So we have the question maximal rectangle, yeah, and everything's fine, yeah. So first of all, I haven't solved this question because I was first of all trying to understand the approach of this question, because yeah, just couldn't understand what the question asked, and I was trying to narrate the approach in my head, whatever I learned by watching the video. So I'll try to do it at the moment. Now the thing is that with this question, yeah, with this question, we need a prerequisite, that is maximum largest rectangle, like largest rectangle in the histogram, like not topics. Yeah, largest rectangle in histogram. That is the prerequisite of this question. Now, what this question asks, that is the main thing. So basically the question is very simple, that I have a 2D matrix, I have ones and zeros, and that's it. I need to tell the maximum area that I can find in the matrix. So here I have the matrix, I have to tell the maximum area that I can find in the matrix. Now and yeah, the largest rectangle containing only ones, find the largest rectangle that contains only one. So yeah, whatever area we're going to find, that area is going to consist of ones only inside of it. Now what has to be done, how to approach this question? So first of all, let's talk about the prerequisite of this question, that is largest rectangle in the histogram. What was in that question? We had bars 2 and 3, and bars were basically the array that we were given. So the thing was that, for example, I'll put this right here. We had array, we had 2, 3, 4, 5, 1, 9. So what we had to do was, we had to find the maximum area. So suppose, for example, we are at 3, right? Or suppose, let's say we have this as 6. Now we are at 4, for example. Yeah, let's write the indexes below them as well. 0, 1, 2, 3, 4, 5. Cool. So now the thing is, in this question, suppose we are at index 2, that is the element 4. Cool. Now when we are at that particular index of and that element, what we need to see is that how can we form the maximum, like what we need to see is that till what extent can it go, the width of the rectangle, because we know what's the height is 4 for the element 4. 4 can only go till 4, right? So height is 4 only. What we need to find out is, what is the width gonna be? Cool. So we know the length or the height, but we have to find out the width. So we multiply that and we get the area. So for that, we need to figure out the indexes. Yeah, we need to figure out the indexes, till where can height 4 travel, so that we get a rectangle wherein 4 is all set. That means either we encounter an equal element, that is 4, or we encounter something greater than that. So for example, if on the right side of the 4 we have 5, yeah, it's fine, we can go there, it's fine. If on the left it has 6, alright, we can go there, it's fine. What if it has 2 on the left, and what if it has 1 on the right? So we are going in these directions. First of all, we are going in right. We have, right now we have 4, we go here, we have 5, it's fine. But the moment I encounter 1, it drops. So here I have a particular index 4, and I'm going in left. I am at 6, alright, that's fine. I encounter 2, it drops. Here I have a particular index, that's 0. Let's write them down. 4 is having the index of 2, and this is having the index as 0 and 1 is having the index as 4. Yeah. Now what has to be done? What has to be done is that we will be subtracting them, you know, we will be subtracting them. That is what has to be done. We found out the next smaller, we found out the previous smaller. Yeah. So when we know that the previous smaller is 0 and the next smaller is 4, so we need to get the width between them. Yeah, we need to get the width between them. What if it would have been 1? Let's take that. Yeah, so now the next smaller would have been 1. So yeah, this would have been the case. This would have been the index. Cool. So we would have done 4 minus 1, that would have been 3, right? That would have been 3. Formula says have a minus 1 more because it's 0 indexed. That would have been 2. That means 4 into 2 would have given us 8, right? Why did I run that? Yeah, 4 into 2 would have given us 8. Why do I say that? Our index 4, we would have had it to travel from, like, from 4 it could have only gone till 5. Yeah, because it can't go here, it can't go here, so from 4 it would have only gone till 5. That means 4 and 4, so 2 bars of 4, that is 8. Cool. So we know the formula. So now that's how we got the, maximum rectangle around for the index, for the element 4, for the index 2. Yeah, pretty simple, pretty straightforward. How to approach this question with this understanding? Let's figure that out. So now again a prerequisite is required, that is prefix sum. Yeah, how do we do that? What are we going to do is we're going to take we're going to traverse in row first. We're going to stay in the same column, we're going to traverse the row. What are we going to say? We are going to say that, listen, for the particular column, for the column 0, we're going to change the rows, we're going to keep changing the rows. So what are we going to get? First of all, we're going to get 1, then we'll get 2, then 3, then 4. 1, then 1 plus 1 2, 1 plus 1 3, 1 plus 1 4. Yeah, and the moment we encounter a 0, it's all done. Cool. It's all done, we don't have anything. So 1 1 1 1 0, it's all 0, right? That's how it's going to be. Why do I say that? I say that because of one reason, that think of this as a histogram. The bars of the histogram, they're going to go up till 4 from here, but if they have no start, if they have no foundation, you can't have a histogram of any height. Whatever the height was on top, if you don't have a base or the bottom, it's of no use, right? It's of no use. So we are going to do that for every level. All right, we are going to do that for every level. How do I, like, what do I mean by that? I'm going to say that we will be having a matrix. Let's create that matrix, right? Let's create that matrix. It's going to be 0, then it's going to be 0, then it's going to be 1, then it's going to be 0 again. Yeah, it's going to be 1, it's going to be 2, it's going to be 3, it's going to be 0. Yeah, now it's going to be 0, it's going to be 1, it's going to be 2, it's going to be 3. Yeah, cool. It's going to be 0, it's going to be 1, it's going to be 2, it's going to be 0. So this is the matrix that we will be having after I add. everyone. Yeah, after I add everyone, this is the matrix that I'm gonna have. Now what do I have to do? That is the main point. Cool, that is the main point. What do I have to do with this? How to apply this histogram logic on this matrix that we got? If we look at it, we have a histogram. Yeah, we have a histogram. We have a histogram. So what my point is that we will be requiring, suppose we took an array here. Yeah, we took an array here. We'll have to do the same for this as well. But now the question is, around what you are gonna apply the histogram logic. What is the array that you're gonna take? And that is the question, that is the concern. Like, what array are you gonna take to get us, the answer of what? Answer of the rectangle's maximum area that only has one. How are you gonna do that? All I can see is that this is what we are required. Not all, but 2, 3, this section started from 2 and this, this one. This is all that's required. Yeah, output is 6. If we see right here, 2, 3, 2, 3, 2 into 3 is 6, right? So how do we approach this question? That is the thing. How do we approach this question? Let's try to figure that out. How do we approach this question? If we will take every array like this, every row as an array, and for every element, if we try to take out the area for this particular row, which is one of the row of the answers, for this row at this element, if you're trying to take the next and the previous smaller is going to be this, so it's going to get stuck right here, 0, 1, 2 at 2, index 2. Next smaller is index 3, it's going to get stuck right there, 3 minus 0, 1, and 0, 1, 2, 3. 3 minus 1, it's 2, minus 1, it's 1, so 2 into 1, it's 2, right? For this, like that, same way we're gonna get 3. Yeah, understandable. Why would this approach satisfy any other case? That's the question. How is it possible? Just why is this satisfying the case? That's the question now. like till this place it was like height was 2, so the maximum area of the rectangle is like 2, for this portion. No, that was 0. It's 1. Till here it was like 2, so yeah, this rectangle. Till here it was 3. Till here it was 3. Why is it satisfying? Like for example, wait a second. Yeah, I mean, for this portion, I get maximum area or something. Largest rectangle. For this, I get a large rectangle. This I get a large rectangle. For this, I get a large rectangle. Right? What then? Yeah. What's then? Wait a second. Let me understand the approach. Ah, okay. Every row has like the base. That's what we're doing. Um, this is like base is 1. At this, the base is 2. I understand that. At this, the base is like 3. It's gonna cover the bit of the group. Yeah. Like for this particular area, the max height is 2, so it will be covering the elements of it's not going to go further. That's the point. Yeah. So yeah, I mean, with this, it's gonna be 3. That's the thing. But um, the index is 0, 1, 2, 3. 3 minus 1 is 2 minus 1. Why am I getting 3 with this? What's gonna be for this? 0, 1, 2, 3. Yeah, it's gonna be 4 minus 2 minus 1 is gonna be 3 as well. 0, 1, 2, 3, 4, 5. 5 minus 2, it's 3 minus 1. So for this, it's 5 minus 1, that's 4 minus 1. Alright. Yeah. I don't know why I was messed up with this 3. I don't know why. The 2 was the answer. That was gonna give me the answer. But why this approach works? I mean, kind of is understandable, I guess, because here we have like height as 3, we have it as 2, we have it as 1, I mean 2 as well. For this 2 we can go here, we can go there. Yeah, what's the answer, brother? Okay, so let's get away with all the stupid understanding. Let's get back to the question. How much time have we? Yeah, it's 25 minutes in the video with just the explanation. Wow. Yeah. So let's get started with the question. Let's try to do it under 20 minutes, not make it a 1 hour video. So what's it gonna be? Let's do one thing. Let's make a question, function that is gonna be, why do I write private? I don't know, but yeah, it's gonna give me largest area. Let's have it an int type. Cool. Let's have it an int type function that's gonna be giving me largest area. Cool. It's gonna take what is gonna take into it? It's gonna take a singular array, so we can have, you know, I mean, char only, I don't know, we'll see. Whatever the name can be, don't care about that. So what I'm gonna do for the largest area, what do I have to do? To find out the largest area, I have to have an array that I am taking from the user. What I'm gonna say is that, alright, for this particular array, I'll be giving you an array of next smaller element for that particular index and the previous one and the next smaller. I'll be giving you 2 arrays for it. What you have to do is you have to subtract a -1 from it as well, both of them, and then multiply it with the index. That's what it's gonna be. So let's try to put, publish it on that thing. So I'll have a stack, I'll say of integer type, I'll say st equals to new stack. Yeah, cool. I have a stack. What I'm gonna do, I'm gonna say, I'll say equals to answer dot length. Yeah, what I'm gonna say, for int I equals 0, I less than n, I plus plus, we are finding previous smaller at the moment. I'm gonna say while is empty, while it's empty, and the element that we're gonna have of answer I, if that element is smaller than whatever is present inside of the stack, that is st dot peak, st dot peak from answer, comparing it because we have index into it. If what we are gonna put in is gonna be smaller, it's gonna be smaller than what's already present. If that's gonna be the case, then what do we have to do? We'll pop it because we don't need anything greater present in the stack. Else what we are gonna do is, we're gonna say that let's have an thing int psi is new int with n. Cool. Previous smaller index. I'm gonna say psi's I will be if it's empty, if it's empty, then if it's empty, if it's true, then you can have it as minus 1. Else, if it's not empty, then what you can have it is as peak. That's it. Cool. And then we'll say answer I. Cool. We'll push it. Oh, we have to just push the index, so don't worry about that. This is done. I'm gonna go dot how to clear a stack. How to clear a stack. st dot clear. Cool. Let's do one thing. Oh, my bad. Yeah. st dot clear. Alright, we cleared the stack. Now what we'll do is we'll copy paste this same thing because we can. I'll say nsi, it's new int, if I is equal to n minus 1 greater than equal to 0 minus minus, if it's empty, if answers I is moving ahead next smaller, if answers I is smaller, then yeah, pop that, because I removed my thing. But if I have 4, if I have 1, if I have 2 here and I have 4 here, it had 4 in the stack because 4 is the last element, because stack was empty. I popped it in, I pushed it in, by the way. Then I encountered 2, then I'm going to be like, alright, is 2 less than 4? Absolutely it is, so I don't need 4 then, of no use. I'll remove it. I push 2 in the stack. Cool. So if that's the case, if of peak, cool, pop. Yeah, it's fine. This is gonna be n. I'll push I. Cool. Now what do we have to do now? I have a psi and I have a nsi. What has to be done is now I'll have to calculate the maximum area for the array that I'm getting. So I'll have a for loop that's gonna have int I, that's gonna start from 0, and it's gonna go till n. It's gonna keep incrementing. Then what's gonna happen is that, alright, for every particular element, now I'll be following a formula. What I'll be doing is I'll be having int sum equals 0, yeah, or let's say int area as 0, right? What I'll do is I'll say area equals to math dot max. I'll say that either area is the maximum or num, wait a second, or yeah, for the particular, in the array for that particular index, psi is I, that is, yeah, cool. Nums I, it's nums, what am I inputting? Answers. Change it. It's gonna be int. I won't be having a character input. It's no use. Int y. Answers I into previous I minus psi I minus wait a second, why can't I have int left equals I minus psi I, and int left or right equals nsi I minus I. Yeah, why do I don't have it? But I'll have to declare I then. Okay, it's fine. I'll have it inside because it's gonna get changed for every other element, so I guess it's gonna go and be fine. you know, what just happened? That's weird. Okay, so I'll have int left and int right. Then I'm gonna be like, remove this completely. Remove this. I'm gonna be like answers I is equal to left, no, right minus left minus 1. Let's have it all together inside of a bracket. Absolutely fine. That's gonna be my area. I'm gonna return area because I'm gonna get the maximum out of it. I guess it's pretty fine. Now all I have to do is I'll have to implement the prefix sum logic right here. So I'm gonna be clear with the basics. I'm gonna say int n, it's equals to matrix dot, you know, length, and that's the length of the row. And I don't think I'll need it, but who cares? Let's get it in. It will be easy to show the complexity analysis. What I'm gonna do is now I'm gonna say that create int answer, no doubt create that because I need that. New int, put in it as n, nobody cares about that. It's gonna be same n or m. Then what I'm gonna do is I'm gonna say that let's have a for loop. I'm gonna traverse the rows, not the column this time. So I'm gonna start with j. Cool. I'm gonna start with j. See, now here I can use a normal for loop or an enhanced for loop. Nobody cares. Absolutely. Because if I'm gonna start with, you know, the rows, like I have to stay in that particular column. So what is this representing? This thing is representing a row. This thing is representing another row. So whatever is inside, that's representing a row. So if I pick one and I keep traversing further down the line with the rows, it's gonna be fine. So like for example, if I pick a character, I mean, yeah, who cares? I can just have what I know better. I can have it as j. Why? Because yeah. Why do I have it as j? I'll tell. Because I am traversing rows. So column has to stay the same. J is the column. So yeah. Yeah. I less than n I plus plus. So now what's gonna happen is if wait a second, int sum has to be 0. If matrix comma j equals equals 0, sum equals 0. Why do I do that? Because if it's gonna be 0, it's gonna be 0, that's it. I won't be having any sum right here because there is no starting point, so it makes no sense. If I'm clear with the case, then what I'm gonna say is that how do we get the prefix something going up? How do we do that? Yeah, how do we do that? I'm gonna say the array that I'm creating, what I'm going to do is I'll create an array. I'll create an array for that particular column of all the rows. wait a second. How? This is the final step of implementation. How do we do that? 40 minutes in. Thing is, that one is for the column. This one is for the rows. So I'm gonna traverse. I'm gonna, for this particular column, for this column, I get a answer. I'll get all the columns right here. When the J column changes, I'll get it for them. How do we implement that? I forgot. Can't get my head around it. Because within the same thing, I'll have to keep doing it for the matrix as well, the largest area. How do we do that? What has to be done? Let's try to understand that what has to be done in the question. In the question, what do we require is that we need to make sure we get all the sums together. So for each and every level, we have a sum. Yeah. How do we do that? We do that by traversing every column. So for example, if we are in column 1, we traversing every row. If I are in column 1, if j is 0, we are in column 0. My I is at 0, it's 1. Cool. So sum equals sum plus matrix I j minus this thing, stupid thing, yeah, minus this, add this, yeah, we'll add this in sum, yeah, we'll do that. It's gonna go to all the i's. One, it's gonna be 2, and it's gonna be 3, it's gonna be 4. It's gonna go from like this. I'm trying to understand how do I get an array out of it. Should I create a new one? Absolutely I should. Why not? Why I didn't think of it? Why I was struggling with no reason to struggle? Create a new matrix, call it prefix sum matrix. Absolutely. Who is stopping you? New int. My goodness, one bad click, it's gonna get messed up. I'll do that. I will do that. I'll have a prefix something. So I'm gonna say my prefix sum and j, my prefix sum for 0 with I and for 0 with column, what it's gonna be? What is it gonna be? It's gonna be the sum. Who's stopping me to do that? If I'm gonna come right here, my j is gonna say the same. Now what's my I gonna be? What's my I gonna be? It's gonna get added, sum plus 1. Yeah? What's my I and absolutely. When I'll exit the for loop, I'll have, I'll have this, right? I'll have this whole thing done for me. I'll move, I'll have this, I'll move, I'll have this, I'll move, I'll have this. My prefix sum is gonna get ready. Yeah? My prefix sum is gonna be ready. Okay. What's next? I'm struggling because I removed that thing. What happened from my reference? When my prefix sum is gonna be ready, what do I have to do? What I have to do is that I'll have to take a particular row out of it and find out the area. Yeah, find out the area. Pretty simple, I guess. Yeah. For int I, that's 0, I less than n, I plus plus, gonna have the same thing for j, because I'm messing with the prefix 1 right here. I'm gonna say now for this I'm gonna say I made a prefix sum matrix. Now for a particular row I'm gonna say int, I'm gonna create a new matrix. Int answer equals new int n. I'm gonna say answers I is prefix sum I and j. J is gonna get done. So yeah, answers I is gonna be that, right? Now I'm gonna be like for row purpose, and I'm gonna be like for row. Now my columns are gonna get changed. So this is gonna be my answers I. Answers I is gonna keep changing with this thing. Oh, wait a second. Let's get a J. Hey, why not? 0, then 1, then 2, then 3, then 4. My bad. Could have gone worse if I wouldn't have seen that. So the moment I get the answer array, the moment it's all set, what I'm gonna do before I'm done with it, yeah, I'm gonna have a thing known as int max area. What it's gonna do, it's gonna say it's gonna be 0 initially. What is it gonna say? It's gonna say that alright, cool, you have the array, absolutely nice. Do one thing, let's get the max area out of it. Yeah, how to do that? You have a function largest area that takes in an array, that's your answer. Let's have that. Then we'll return max area. How about that? A lot of errors, I understood. Binary operator, what do you need? How about this? Understandable. Answer is defined in the method. Am I repeating it or something? Int answer is new and alright, so I had already done that. Oh, my bad, shouldn't have done that again. Index out of 1 for length 4, where is it happening? It's happening right here. Let's see why is it happening right here. Let's try to understand why is it happening right here. Both lengths are gonna be same. what is happening, what is actually, wait a second, I have called. What is actually happening? How can be index 4 out of bounds for length 4? How is it able to reach the index 4 when it's less than the length? Where is the issue? Alright, now it's taking a lot of time, so I'll just try to just tell me errors, no code or explanation. But where have I had a typo in largest area? Ah, alright, alright. Wait, but if it's through here, so through minus something, so through minus. Okay, makes sense. Understandable. Second left is like it's gonna give me this portion. Tell me how much on the left. Five and six. What's kind of the issue? Wait, what? But why is it giving me an issue if it's all good? Ah, so it was placed right before. I guess the error was just about this equal to thing. All right, understood. Yeah. I hope this passes because I can't do it more. Thank God. So that's it for the question. Yeah.